Hi, good afternoon, everybody. I just want to thank everybody for coming in here and joining us on our webinar for Fab Shop Automation. My name is Brad Stropes. Me, along with Jacob Diefenbacher, put this together for you guys. And what we will be covering today is pretty much an entire suite. So this is going to be a fully automated type shop. Now this is a suite, and all of our products can be sold individually. So we're real modularized, so we can fit all the different shops out there. But what we really want to do is show you what the different products are and what we see coming in the future for our software and for the fabrication environment. So first things first, this is the most automated webinar that we've ever put together. Definitely the most automated webinar that I've been involved with, and really kind of where we're pushing ourselves towards. So some of the things that you'll see that are very unique on here. We're going to take an entire assembly, a trailer assembly, that is just built in simple sheet metal and tubing. So it's going to be basically taken from the very beginning, the solid model, all the way through our tube nesting and cutting, then to what's called our Sigma bend. What that is a bending platform for press brakes out there. Come up with we can actually control the back edges on your press brake, come up with your tooling layout, and send out your bend sequences out on the floor. We're going to go over our Sigma 3D robotics. Our eye's a little bit messed up there, but our Sigma 3D robotics program for laser cladding and welding. A lot of people don't know we have these products, this robotics, the nesting and the bend, or the tube nesting. So it's a really unique webinar that you guys are all joining us for today. Then we're also going to get into our SimTrans ERP integration, then to our flat nesting by work orders, then on to scheduling, shop floor control, and again, this is all from one suite. Now, I just want to make it clear that you guys don't have to buy this all together as a single suite, but a lot of these products our customers don't know we have out there, and a lot of them are really taking the market, and the more and more that people find out about them, the more and more information and the more webinars that we've been holding on them, so we figured we'd do them all together into one webinar. So this is kind of what the workflow is going to look like today. The first thing first, this is kind of what we envision on a normal shop. We have an ERP system where you put in your quotes and you allocate material. Then from an ERP system, if you put in an order, today is going to be an example for a trailer. It's going to go, so from your ERP it's going to be order for a trailer, then down to your solid CAD model. This could be Inventor. We're going to use SolidWorks, but it can use any type of solid CAD platform out there. So don't be if you see just SolidWorks on there, don't shy away because you're using CATIA or Solid Edge or whatever it may be. We're just using SolidWorks for the example today. From our solid CAD, we're actually going to use SimTrans. What SimTrans is it's a transactional database that actually looks at your ERP system, your materials in your ERP system, and it's going to take your orders from your solid CAD. Today, again, it's going to be one trailer. Send it over here for that order, and then all that information, this really should have another arrow here, all that information for your work orders, your other orders, your material that you've purchased will all be transferred automatically over into Sigmatek. The same is true for your other platforms. So the SimTrans actually would be going back out here. It's a pretty large process, so we just kind of simplified it here. But so then we'll be covering at first, after we go in through our ERP system, solid CAD to SimTrans. Then we're going to take a look at Sigma Tube. We're going to go to Sigma Bend. Then we're going to go to Sigma 3D, and then we're going to hop over into Sigma Nest for flat plate cutting. And then we're going to end today by our shop floor tracking and load managing and scheduling. So really, this is going to cover all your bases. The nice thing that I really want to drive home here is I'm a single individual, and I'm sitting behind a single computer, and I'm going to program about 4 or 5 different machines today. Along with that, I'm going to have material transferred over into Sigmatek, and I'm going to have work orders automatically being processed in. So when you're really looking at this, realize that I'm a single individual running an entire CAD, an entire trailer, programming, nesting, posting, bending, also welding, and then also tracking the floor. So I really want you to think about that and think about how many individuals that you have currently that could be running other machines, that you could really allocate to other things, and let Sigmatek take over when it comes to programming and worrying about the shop floor. A little bit of background about our company. I don't want to take too much time on this, but we've been around for 20 years. If you haven't heard of Sigmatek, you know, fabrication, everybody in fabrication really knows who we are. We're by far the leader in CAD/CAM nesting. Close to 200 people started nesting, and now we still nest, and we obviously have PhDs on staff that are always developing new nesting algorithms to save material. But really where we see the future going is more towards the automation section, and that's where our new focus is. We have full solid CAD integration, and as I stated before, we're much more than most people realize. We have a lot more to offer than just nesting. Our presence, I just put this up here to let you know that we are around the world. You have support 24/7. We can run any machine out there that has some profile cutting. We can run, again, robotic welders. So we'll show you everything today, what we can run. Presence around the world, though, but we have support as well. Here we go. This is our machines that we run. So water jet laser, but again, like I said, you know, we are also into robotic arms now. Here's our tube, knife, oxy-fuel, CNC router. So basically, if you cut it, you know, most of the time we can run it. This is also true with, we're looking at some more saws that are coming into play, more automated saws, some of these beamline machines as well, and some coping machines that we can run with some of our 3D products in our DSTV exporter. So even though we're going over pretty much everything we have today, we still have a lot more to offer, and we can run just about all your machines out there. So if you have any questions, feel free to ask us. What makes us unique? Again, I need to hurry up. We only have a certain amount of time here, but we're cutting edge. Really, we're driven by our customers and our customers' needs, and we're always looking into the future. We provide a custom solution, 12,000 users worldwide. We have, again, more than most people are aware of. And this is one thing that I really want to hit on today. We have a services group. In our services consulting group, what they do is they specialize in plugging in our different products into your process. So as you see here, let me go back up here. As you can see here, this is your ERP system. Every ERP system is different. What we've done is we have modified SimTrans to pull in this information. If you're using a vaulting system, we can automatically pull in from your vaulting system as well. And we can really use our consultant group to really streamline this process, get it into SimTrans, and then out to our other products. So it makes this unique. Here's my contact information, Brad Stropes. I'm the sales manager for most of these products, all these products really that you see here. I focus heavily down in Texas, but when it comes to 3D and tube, I also play a huge part in that category. Here's my email address, and here's my telephone number. I'll put this back up again at the end so you can contact me if you need to. So what we're going to do is we're actually going to hop right over, and we are going to start. First thing first, we're going to open up our CAD model, and we're going to process some tubing for our tube lasers. Like I said before, we can run just about anything that's out there. So if you have a tube laser, saws, plasmas, coping machines, Python machine, pretty much just about anything when it comes to a linear nesting machine. It doesn't even have to nest. If you just need some intricate programming, we can take care of it. So this says SolidWorks, as I said before. Just ignore that because if you really wanted to pull in just about anything into this platform, you can. So even though this is a SolidWorks model, if you want to import an Inventor, Solid Edge, CAD Key, Rhino, DSTV, just a dummy Parasolid, we can. So just ignore that, but that's just kind of the platform that we're looking at right now. So here's our model, and like I said, what we're going to do first things first is we're going to process this tube and get our tube programming out to our tube laser is what we have set up currently. So what we need to do is we need to go in here. We'll have our add-in that's sitting right here inside a Sigmatube. What we need to do is we need to go in and we need to process our parts. What processing parts does is it looks at all the different material types and thicknesses that we have. After we process these parts, we can go ahead and close these parts out. And what I'm going to do is I'm going to break them out and auto task them by material type and thickness. The next step I'm going to do is I'm going to generate our toolpath. Okay, now that we've processed the parts, we've actually gone through and we generated the toolpath. We just need to auto nest these parts out and we will post them out. If you guys have a tube laser out there currently, obviously this is a very automated process. We have all the manual processing as well. I can come in here and I can make the changes, make the whole changes, but for time purposes I can't adjust the cut quality, auto tabbing, lead ins, lead outs, edit the toolpath, whatever is needed. But if on this automated process, if you guys are running a tube laser or tube plasma out there, and you just saw that process, a lot of times our customers are just completely blown away. One example we have, and we've auto chucked it and everything. One of our customers that we've had did a boom for a crane, and with that boom, it would take them about 3 days to design the entire crane, and then to part it out, it would take them a day. To program, it would take them another day. So really, it was taking them about 2 days of programming, and they weren't even nesting; they were just individually programming parts. We went in and we did their entire boom in 12 minutes. So we went from a 2-day process into 12 minutes. Now, some people think that's unbelievable, but if you have an assembly and you want to send it on over, I'd be happy to do that and take a look. Here's some channel. So we programmed our channel as well. We have our tech table set up so we can run all the different machines out there. And we automatically apply our cut speeds and feed rates as well. So here's just a short tube that we had left over, another short tube, and then there's our entire assembly. So what I want you to realize is that it just took us a minute to program all the tubes inside of that part. Now, what we also had in there was some fenders and some flat cut parts. What I'm going to do now is I'm going to exit out of tube. So what we'll do is we also have programming, we have reporting. So because of the time's sake, we can't really go into all the details that we have on Sigmatube. If you would love if you'd like a demo, I would love to give you one. So just give me a call or shoot me an email, and I'll take care of that for you. So we have our fenders. So what I'm going to do here is I'm going to actually show you our fender that we have for Sigma bend and how we will actually go down and we will bend this fender here. So here's one of the fenders. Now we can do this automatically as well. We can pick out the sheet metal and send it over, but for demo purposes I just want to show you kind of how we're doing it. So this is even more of a manual approach for Sigma bend as well. So we'll open this up here. And now what Sigma bend is it is a complete unfolding and sequencing platform for press brakes. So we can model your press brake in here. We can even write up a post for most machines out there. Even if you don't have a post or don't want to post, it's really nice to have a setup sheet for your machine. If we go right in here, then we'll go into SolidWorks, and here's our part right away. It's that quick. And what I'm going to do is I'm going to go ahead and unfold it. It'll unfold it based on our K factor and give us our flat pattern. Now when I save this off, this flat pattern is actually going to be sent over to SimTrans, so we'll automate it. So at the background, just always remember as I'm going through these and programming these parts, it's also going into our scheduling into SimTrans from our ERP system. And the next thing that we're going to do is we're going to go into bending. Okay, so here's Sigma bend. What we need to do now is we need to go in and we need to automatically have it come up with our bend sequences. What we have is we have different criterias, and we can add additional criterias that we want to change. So our criteria here is station, gauging, turns, Z movement. So this is stations that we need to change for our tooling when it comes to bending. So what I'm going to do is I'm going to go ahead and hit search, and what it's going to do is it's going to run through our criteria, find the least amount of station changes that we have for this. Okay, for time purposes, what I'm going to do is I'm going to go ahead and stop it. Based on our stations that we have here, we came up with the ability to bend that part with 2 station changes. Okay, now that it's done, what I'm going to do is I'm going to go ahead and hit OK. And what you'll see is you'll see our machine coming out with our different stations that we have. Okay, and now what we're going to do is we're going to calculate our tooling. You can add in and you can draw in your tooling. Most of the tooling that we have are from the large tooling manufacturers already. So most of the tooling we already have. And the next thing that we're going to do is we're going to go down and we're going to look at our different display options. So we can have the entire machine design in here, which is 3, or we can go all the way down to 1, which is our tooling display only. So we'll leave it here for purposes, but we can always go back to 3 for the entire machine. So the next step that we need to do is we need to go in and we will take a look at our simulation. Make sure that there's no machine crashes. If there are any machine crashes, we'll be warned automatically. And you'll also get a full tooling setup in a tooling library. So this is actually a real interesting part. This is a customer's part and it looks really good. It bends really well. And what we see a lot of people doing is they're actually going into the bending program before they're even nesting to make sure that their design is able to be bent. That way that when they go through the cutting process, they don't have to change the engineering part. Okay, so after we have developed the bend sequence, we can go ahead and NC and send that right out to your machine for your back gauges, and we can send it out to your control. And we can also go into our process documentation. So I'll do is I'll go through here, I'll save off our documentation. What this is going to do is it's going to take multiple different views of this bending sequence, all the tools we need based on our machine, the NC program, the time that's needed, pretty much anything that's needed. So think of how many blanks that you cut out on the floor now to go in and bend and sequence your bends and come up with a proper product. When with Sigma Bend in a couple of minutes, you can come in here, have your total NC program driven to your back gauges, have your tooling all set up, have a bend sequence, and ensure that this part is bendable before you even produce it. So you can see why a lot more people are looking at a bend program than they were in the past, you know. And on top of it, the press brake world, the bend guys, they're getting further and farther between. It's a very technical position. So it's nice to have an offline program that you can go ahead and send this out to. Now that this is bent, what we'll do is we're going to hop back over. So now that that's bent. And again, remember that this is all sitting out on our shop floor and sitting inside a SimTrans. So as I'm going through this and as I'm saving off these parts and saving off this programming, it's all going into one retaining file, and it's being dispersed out to our shop floor and being ready and being imported into Sigmatek to be cut. So now we have our tubing that's being cut. We have our flat pattern that's out there being cut. The one more thing that I want to do is I actually want to go in and I want to program for a robotic laser and our laser cladding or robotic welder for external programming. So I'm going to hop over here. This product is called Sigmatek 3D. So here's Sigmatek 3D. What this is you can see this is a KUKA robot here, and within our KUKA robot you can have your welding or laser cladding. We can also run robotic and 3D cutting platform as well, so all from a single platform. With this, what it does is we have automatic tool pathing already generated. So what it does is it looks at any type of open contours, realizes that it needs to weld inside those open contours, and develops a tool path for our robotic arm here. So as I go through here, what you'll see on our back end is I'm going to go in and I'm going to simulate this. Now this table has a movement to it as well. KUKA is a good friend of ours, and Oxypura develops the KUKA robot. So we have a NC program, but we can also run multiple other robotic arms as well. So what I'm going to do is I'm going to click on simulate here. I'm going to walk you through, pretty simple, but it's going to make that turn. It's going to go in, and again, we're all in a 3D platform. If I want to go back in and change any type of any type of engineering or geometry, I can. But just that easy. There's nothing that gets easier than that for robotic welding. Most of the time they have teach functions. What we also have is, you can see up here, again for time's sake, if you have questions on this, I can get into it, but we can design fixtures for you automatically. I know that's a huge advantage of our software over anybody else's software. And you can also do manual tool pathing as well. So you can do this again with cutting, or this is a robotic welding platform. Also in here, we can design this to fit any of your machines. So if I go in here and you want to maybe see the machine frame, we can pull that in. If you have different platforms with different movements, we can design your entire cell. Okay, so now we have unbent our part. We have programmed our entire trailer, sent the program out to our laser machine. We also have our programming done for our fender. All of our programming has been sent over into SimTrans, and SimTrans has now sent it out to the floor. So what I'll show you real quick is what SimTrans looks like. So what I'm going to do is I'm going to hop over. SimTrans runs as a service, or it can run as an intermittent program that you start up every 10 minutes, every 15 minutes. But again, we can't run it as a service if you want it running live all the time. What it does is it sits in between your ERP system, it sits in between your solid CAD system and solid modeling system, or your vaulting system. DXF, DWG automatically pulls them into our program and then disperses them out to your different machines and your programming out on the floor. So what we're going to look at next is SimTrans to Sigmatek. So I'm going to hop over to my other computer here, which is our server that this is going to be sitting on. Okay, so now we're switched over to SimTrans, and what I want you to realize is SimTrans may not be the prettiest platform, but what it does is it sits on your server, and what it does is it looks at your orders, it looks at your vaulting system, your DXFs, or your file folder that you store your drawings or your geometry in, and it also looks at your information from your ERP system when it comes to the inventory. What it's going to do is it's going to load in work orders, just like your jobs inside your ERP system. Send those work orders, that inventory, unfold everything from SolidWorks or Solid Edge or whatever it may be, and then it's going to automatically import that and send it out to your shop floor to Sigmatek for our nesting platform. As you can see, it's already making our transactions. This is totally customizable, and then also out to our other platforms as well for our shop floor. Okay, so now we're back. We're going to go over to our flat plate cutting platform, Sigmatek. I just wanted to give you an overview of what SimTrans looks like. You'll never actually see SimTrans run. It runs in the background, but and like I said, it's not the prettiest program that we have, but it's extremely effective, and it's very diverse that it can plug into just about any ERP system. And what it does after it sends over our ERP system, it actually does quite a bit. It's going to unfold your parts, like I said, from your solid CAD. It's also going to import any DXFs or DWGs from a file. It's also going to import your sheets lists directly from your ordering platform. So if you have a purchasing group and they purchase 120 by 60s, that material will be sent over. It sends it over with our material type, quantity that's received, heat number. You can even attach your material certs if you would like to. So that's going to be automatically filled in by your ERP system. It's also going to fill out what we call our work orders. So our work orders, now here is that work order that we sent over. It was customer 5. We also have your CRM module that can be linked up to here. You can also run this independently. But here's all those parts. Here's that really nice part that we got from our bend application that said it was good to go, bending from Sigma Bend, and then the rest of our parts here. A priority level and a due date up here. So you can see our due date is a little bit old, but it's still all right. We just need to update our time here. What I want to walk you through quickly, so that'll be an automated process. Well, let's say that you have a customer that's called in now and he just wants some DXFs that are sent over. You don't want to enter them in your ERP system, MRP system. He just wants to send over some DXFs and get a quick price on these DXFs. Well, we actually have an answer for that too. So what I did is I just put in some example DXFs here, interactive mapping. If it has tags, we're going to pick up the material type. If we have our part parameters or our tag settings set up here where it's part number, material equals material. So we can automatically pull in our geometry. We're going to say OK here and import our DXFs then that were sent over by this customer. So on one hand, we have our MRP ERP system running in the background. The next thing that we need to do is we have a customer that's called in now and he wants a price. So I'm just showing you how diverse we can actually be with all of our different pricing in all of our different ways that we actually interact with different customers. We should go in here and I'm going to turn off for a second this color and we're going to just do a normal color. Here's our DXFs that we put in here, and one thing that a lot of our customers don't know we have is this costing module. This costing module is extremely diverse. What it does is it looks at our material cost based on density. We can give it a markup percentage that we give based on a different customer, and then we could actually come up with our routes for this, and we can actually store this on a route card for you. So if we want to come in and we want to add a number of bends, grinding length, number of tracks, we actually have a back-end database for this. So anything that you need in here, if it's number of bends or assembly time, we can add that by you adding in minutes. It actually calculates that automatically, creates the routes, and then we'll store that off. Now, not only does it create the routes and length and material and density and calculated run times, but what it's going to do is it's going to give you a really nice quote. So we'll just keep it ABC Engineering. If I wanted to have a contact in here, we can have a database behind here, but I'm just going to say OK. And what you're going to see is you're going to see a quote that pops up, and you're going to get several different costing here, several different costs and prices. So we're just going to go ahead and show our unit cost. If I would have nested this, what it does is it breaks up the actual remnant and the drop and allocates that cost between all the different parts for all our different customers in a rectangle cost, which is just drawing a big square around the individual parts. What I can do from here is I can submit quote. We can submit this quote to our customer. We can select our quote. We can come up with a cover letter. This quote that I have for a document, it's just real simple, straightforward. We can have pictures on here of all your parts for your customer. And then right from here, what you can do is you can actually email directly out of here. So you can email that over to your customer. Now our customer calls back, and now our customer wants to go ahead and turn this quote into a work order. So just like we did with SimTrans for our ERP system. And remember, our SimTrans doesn't only work one way. We can actually shove information back into it. So when I convert this to a work order, this work order could go back into our ERP system to let them know that we have an open work order. I'm going to hit convert to work order. I'm going to save it off here. And now that process is complete. So that's a quote, that's a ERP system. Now let's get into nesting. So you have your programmers out on the floor, and their daily task from now on won't be to go in, clean up geometry, figure out the geometry, figure out what orders there are. They won't have stacks of papers on their desk anymore. What they'll be working from is this work order screen. Now we went over our work orders here like you saw before. Now we have an additional work order. But here's our work orders that you saw before. What I always tell my customers to do is use the work orders by parts. What this is a really nice view to say, I want to see everything that's actually due today, and I want to see everything that's due today by material. So on 10/25 I have some mild steel. On 10/29 I have some mild steel as well. What I'm going to do is I'm going to load these automatically, and I'm going to import these. Now every time that I do something like this, we have a customer who comes up and they say, but listen, if I mix my work orders, the guys out on the floor and myself, we don't know where they go next. Now what you can see here is we actually have colored by work order on. The nice thing about this is that it automatically will color the different work orders for you, so you can actually divide them up, and we actually have that out on the floor. We're actually going to get to that next. So the next step is we're going to create a new task. We're going to select all these parts. Material mismatch is okay for right now with our for a demo. And what we're going to do is we're going to look at our library, and we're going to take a look at not only our stocks parts that were our stock sheets that were sent over from our ERP system, but we're actually going to also do some remnants. So if you take a look here, another really unique feature of Sigma Nest is the ability to track remnants. We also have the ability to track parts with certification by remnant and heat number. So if you are trying to be ISO certified, or you want to know that you had a couple of bad parts that were cut by what type of material, we have full tracking traceability as well. From here, I'm going to load these sheets in here. Again, I'm going to get that material mismatch. And what I'm going to do is I'm going to use a portion of Sigma Nest that's called Use Best Sheet Analysis. And what this is Use Best Sheet Mixed. It's going to look by all the different sheets, all the different parts that we have in here, and automatically come up with the best sheet material that we have. So, and what you can see it's doing is it's pulling in all those different sheets from the floor. And here it is with our cutouts. You can actually draw these sheets in by our CAD program as well. So we do have a full-blown CAD program that sits inside of Sigma Nest, and save those off if you already have a CAD program itself. So now that it's completed, what we're going to do is we're going to Auto NC. Looks like we actually used a full sheet here because it had the best utilization. If it would have been you know, a remnant, it would have had a remnant there. We're going to program it, and then I can also go through and I can show you quickly our reporting here. Okay, so here's our reporting center. We have our run times, we have our material costs, we have our thickness, and we have a lot of different reports here for you. The ones that I see a lot of are these part label. We actually have a part label barcode, and tool changes if you're using a punch out there. If you do have any questions on any type of bevel machines, punching machines, router machines, this is a simple laser machine, but we can run any machine that's out there. So just let me know what you'd like to see. I'll get online and we can do a demo, or I can come and visit and we can do a demo. But we'll just do a quick layout detail and a nesting report. And then also our layout detail work order report. And here you go. So full reporting suite. These are all adjustable to whatever you want to see, whatever you want to show. Our NC too, we have full capabilities. Our common line cutting is above and beyond the best out there. Our program is actually written all here, all in the U.S., all written by individuals based out of Cincinnati. It's not a third-party system that's brought in, so we have full customizable capabilities for you. But we're going to say OK to this, and then here is our post. So now that this is done, I'm going to head over here and I'm going to do post all sheets. And now we're going to be getting into our shop floor. Okay, so now that those sheets are posted, we're going to get into our shop floor programming. So our shop floor programs include a couple of different programs, but one of the best programs we have is what's called our Load Manage. Our Load Manage program is based on different groups and your scheduling for your program. So you can see our time here, and we have our different programs that were sent out for our laser. It's a fairly simple program, but what it does, it's actually simple to use, but it's extremely robust. So we can drag and drop our programs, and we can drag them from one. Here's two machines. I can even drag it down to this other machine. That's actually an oxy-gas machine, so we won't be able to actually pull it down to that oxy-gas because it won't allow us. But let's say that this laser went down and we had a secondary laser out there. Or what we can do is we can create groups, so even if we can be cut on the laser, but it can also be cut on something like the punch, you can drag it right from here, you can drag it down, and it'll automatically repost to that. Using schedule in holidays, you can view times, you can view users that are logged in here as well, and even search programs. If you dive down in here, if you actually open up a program, you can see the sheet name that's used, and you can even see what parts are being cut on it. So it's a full Gantt chart that's interactive, and you're actually posting out as you're dragging and dropping them, and you're planning them out on the floor. So there's a lot more power to this as well. But the final step here then is actually what we call color offload. What color offload is a program that sits out on the floor for your users out on the floor to know what needs to be pulled off of the different sheets of the material. You can get actual run times back by this, which is a huge advantage, so you can really dial in your tech tables. And they can know what maybe their secondary processes are, or the work orders that they go on to based on our different colors. One of the best features that we have out on the shop floor data capture, or color offload, by the color offload, is the ability to actually go in here and reject parts. So you can actually have a guy that's running this out on the floor that wants to go in and reject your parts, and you can say maybe wrong material, poor edge quality, and you can actually touch screen these parts and use maybe a tablet to go out there. So I'm going to say that that's poor edge quality. We're going to say okay. I'm going to say not because of Sigmatek. No, I'm going to say that we had poor consumables. I'm just going to say okay then, and that's scrapped. When I do an update here, what it's going to do is it's going to consume that material. It's going to save our remnant, send our remnant back to Sigmatek, and it's also going to load this automatically back up into our work orders inside of Sigmatek. So our programmer then can go back into Sigmatek here, and he would actually go into our workspace and go into work orders, and he would have a hot work order item loaded in here automatically. So now that we have it out on the floor, it can move on to our secondary operations like bend, and we can actually set up color offload by bend if you would like to record time. And we also are making huge strides on secondary processes, and therefore are having a large release here at FabTech for other projects or products as well. So now that that's completed, so we went from a complete assembly over to our tube, laser, and tube programming. From our tube programming, we went to our bend sequencing for our flat parts, for our bend sequencing out to our SimTrans nesting. We also touched on 3D welding. And I'm all a single guy, and I just completed the entire programming with talking in less than about 40 minutes. So that's programming when it comes to welding, programming when it comes to bending, programming when it comes to nesting. All of our parts from an entire assembly in our ERP system as well. Again, this is a full automated system. There's a lot more that goes into it. I'm going to go ahead and pull up this final slide here for you guys. If you have any questions, feel free to give me a call. I'd be happy to come in and visit with you, and we'll go from there. So thank you so much, and I look forward to hearing from you.